the example figure number 2 in the quiz, we take the area like below when if it's a
figure
slant.
number 2. Figure number
Actually,
2.
I don't know. This is gonna be way too hard to do over the phone right now.
Figure. Wait. Figure number 2. Wait. Figure number 2. Oh, I don't have figure number 2 down here. Cole or Mark. Is Mark or Cole asking that?
It's Mark.
Mark, can I finish that question first? Then I come back to.
Yeah, sure. Sorry about that.
No, don't be sorry. Okay. I'm so tongue-tied now, okay?
I have a question about the one we're doing. So does that mean the width of the area for point A would also be 1 millimeter?
Can I do point A first? Okay.
Yeah.
Okay. So point A, right? You can take the top, you can take the bottom. It's the same thing. I'm going to take the top. Okay, I'm going to take the top. Okay. So now the area is this now. Whoa. Right? Okay. So the shear at point A, right? Now the shear of point A is again white flange. Right? So we have Q. So Q at point A, right? So now the width is 2 millimeters, right? And then the depth is what? The depth is 24. Okay, I'm going to take the depth as 24. I don't know what they use, but I'm going to use 24. And the center is 24 divided by 2. So this is 2 times 24 times 24 divided by 2 is equal to 576 millimeter cube. Okay, or 576 times 10 to the power minus 9 meter cube. Okay, so the shear at point A is equal to 5 times 10 to the power 3 multiplied by 576 times 10 to the power minus 9 divided by I, which is 133.76 times 10 to the power minus 9. And then this is 2 times 10 to the power minus 3. Okay, so this is 5 power 3 times 576 power minus 9 divided by 133.76 power minus 9 divided by 2 power minus 3. Hey, 5 power 3 times 576 power minus 9 divided by 133.76 power minus 9 divided by 2 power minus 3 is equal to 10.76. Wait, 10.766 times 10 to the power 6 Pascal. Does that make sense? Yes or no? Okay, now I'm going to address Miriam's question. Okay, Miriam wants me to cover here. Okay, and she says she wants to put a point down here. Right, Miriam? So this is my point M. And point M, the distance from here to here is what? I'm struggling now. Is equal to 25 millimeters, for example. No, that cannot be.
Do it at 14, sir. You go to 14.
Okay, 14 millimeters. Okay, 14 millimeters. Right? So now the first moment of area is where? So if you look at this now, it's still coming down here. Right? Okay. So the area to consider, okay, the area to consider now is this entire area now. Okay. But if we were to consider that area, it is no more a box beam, it's still white flange, because at no point the shear stress is splitting. Am I right?
Why is that whole thing the area if like you have to do it based on the distance between the axis of like shear force? Shouldn't it be like the skinny little part on the left side like it was for B?
At point A is different. You can see what is the difference, yes or no?
Yeah.
Right? Because I'm applying mathematically what is going on, right? When I say applying mathematically, the analysis will start from Y max, yes or no?
Yeah.
Now, if I do this, okay, if I do this, the analysis has to start from where?
Why man?
Have to start from Y max, right? The analysis will still have to start from Y max. And when I pull back, it covers the entire area, yes or no? But the Q for this case is a single Q. It's not a double Q. I know, when you look at this, you say, Eugene, this is a bloody box beam. Yes or no? It's not. Because if you look at the term, if I cover all the way here, okay, if I cover all the way here, okay, if I cover all the way here, the Q did not split, did it?
No.
Right. That is why it's
So
still a
I'm just
white flag.
confused why for B you don't take that whole like little bottom part then if you can't do that for
Because
point
it's relative to the what? It's relative to the
why is M relative to that?
why is what?
Sir, I'm kind of confused again now. I thought I got it, but
Like,
Yeah, I have
why
the
is-
same question as Mariam.
Why
Wait.
is it M relative to the shear axis anymore? Why is it?
Wait, can you all give me time? Okay, can you all give me time? Okay.
Yeah, sure. No
At
problem.
point B is very obvious, right? At point B, like what I draw down here, at point B, when I pull back, it's just we only need to consider this area, yes or no?
Yeah.
Right? That is where point B now. But for this case, if I'm going to apply the rules that I have satisfied, right, we have to consider the whole area. But the thing is now it's no more a what? It's no more a box beam, but it's going to be a what? White flange.
I'm still confused. For M and B, they're both
Oh,
white
shit.
flange, right?
Huh?
B and M,
Yeah, they're all
both
white.
white flange.
Yeah, white flange.
So
I never say it's box beam.
yeah, so okay, so why is the width of the area for B just 1 mm, but then for M it's like the whole thing?
Yeah.
I think it's because B's on a web B's on a flange and M's on a web.
Hey, listen. It's not exactly the same, okay, where the midpoint is, okay? I draw this again. Oh shit, I thought I'm winning. Once you ask that question, Mariam, everyone is confused now. I'm not done my role.
You added a confusing rule.
No, it was not confusing. Right?
So I think you need to rewrite the rules.
Okay. Okay, so now this is point B, right? Right? So point B is just this area, yes or no? Can you all see where
Yeah.
I am coloring is that arrow, right?
Yeah.
Now, point C or point M, somewhere around here is point M. All right. Point M covers this pipe region. It's a pipe region now, right? And if I were to apply what our rules are, that analysis will be from Y max. For this case, it is still a what? A white flange because the arrow did not split. Okay. Now, what I propose is this. Okay. I want you all to like not think about this problem. Okay. I will come back to it. Okay. And I'll give you all an absolute answer. Are we clear? Are we okay?
Yeah.
Okay. I don't want you all to like worry about this because if something I'm not sure, I'm not going to teach. Okay. I want to verify that. Vidu-san, what are you going to say?
so I didn't say nothing, sir. Did I? Okay, let me mute myself. My bad.
Hello? Vidu-san.
I didn't say nothing, sir. I think someone else was echoing. I had my mic unmuted for a minute now.
Okay.
Yeah, sorry.
So what I'm going to do now, okay, I'm going to use finite element analysis. Don't worry about that, okay? I'm going to find out the absolute answer, okay? I'll come back to you guys, okay? And I'm going to apply the rules that I've done, okay? I'm apply the rules, okay? But you cannot say B and M has to take the same approach. Miriam, where are you? Okay, you cannot say that. I show you the difference between B and M now, right? B, the area is very what? Small.
No,
Yes or
I'm
no?
just saying, like, you know, the area for B, why can't you just take that skinny bit and like just extend it upwards?
So you mean just take this bit?
No.
Like
Just take this.
Just
Take this.
Just take
Just
the
take this skinny bit.
yeah, that.
No. Why I can't do that? Because the deriving principle, because the analysis start from Y max. For B, you can. B and M are not geometrically the same. You agree or disagree?
So I'm kind of confused. They're not geometrically the same.
Huh?
Is
They're
it
not the
like
same.
M is in the web and B is in the flange?
Yeah, they're not the same.
But
Right?
why?
But why is it okay? Why is it that so for B, like the width?
Okay,
is
wait.
okay,
Stop. Let me do the analysis first,
Yeah, sure.
and I explain. Now we are just doing one thing. We are just speculating. Okay, and I don't want to speculate because when I'm not sure, I don't want to speculate. Are we clear? I will keep quiet first. I will analyze first, then we come back. Are we okay?
Yeah.
Okay. Thank you so much. Any other questions beside this question? I thought I was so happy you guys are getting it. Now when you throw this in, it does not look very good. But anyway, anyone, any questions, please?
I have a question about the assignment or the quiz.
Okay.
So we're
Okay. Which quiz first?
the one that's due tomorrow, like quiz 4.
Okay. So what about the question, Jacob?
So you're not supposed, like, you don't want us to do like any math, right?
That's why I say it's fun.
Yeah. So like, I was just like, I slept into the tutorial. I was just wondering if like, at the terminals, is it 0 shear stress? Or not necessarily.
Be careful. You have to analyze. I don't want to generalize things. Okay. Like for this case, right? For this case, when I cover the top and bottom, the terminals are no more 0, right?
Yeah.
So I don't want to generalize at all. I think this morning someone asked me about is a shearing stress at the axis where the shear force is applied is equal to 0, right? As I said, I've not seen enough to generalize that theory yet. Okay.
All right, thanks.
Thank you. Mark, you have something. I see your thing blinking, Mark.
Well, I think it's based on this question, and if we're going to leave it, it's kind of pointless for me to ask it. It was just about the analysis of B, comparing it to another example. But if we're going to bring it up another time, I can always bring up my question later.
Yeah, I will do it first, then I'll come back to you. Okay.
Okay, thank you. I'm going to leave now.
Okay, so as I said, this is the ultimate question, but y'all make it worse. And I like that, okay?
Sorry.
It's okay, don't be, okay? I want you to be very, very sure in what you see, or not, you know, if not, you learn nothing, and then when you face to a problem like this, it's frustrating for you guys, okay? And I don't want you to be frustrated. Any questions from anyone? Now.
Yeah, I have a quick question, Eugene.
Yes.
For the end terminals of like an I-beam, is the shear 0, the shear stress?
No, because you have channel moving the shear flow into the center section already, right? Okay.
Yeah. Okay. Thank you.
Right. So because you have Q coming in, right? Right. You have shear flow coming in already. You cannot assume that this is equal to 0, right? No doubt is at the what? Is at the center axis, right?
No, not at the center, at the ends, like at the like the
Over
top
here?
right and top left.
Over here?
Those ones, yeah.
Yeah, they are equal to 0 because there's no area. Q is equal to 0. Q is equal to 0, right? Q is equal to 0, and Q is equal to 0.
Okay, perfect. Thanks.
Okay. Okay, if not, I hope you enjoy the lecture this week. Okay. And next week, what we're going to do is we're going to do 3D pause, moment, and thought analysis. Something different. Okay. If that's the case, have a great weekend. No more
So
studying.
when are we going to like go over this problem and like make sure we understand analysis? Because you said you're gonna bring it up like a later time.
Yeah, next week.
Okay. Next. All right. Okay.
If I've no answer, I'll tell you I've no answer. And don't worry, if I don't know the answer, I'm not gonna ask you in the exam, am I? It's not fair, yes or no?
Yeah. Okay.
Yeah, I'm not are we still recording? Yeah, we're still I'm not a ASSHOLE, am I? If I'm not sure, there's no way I'm gonna ask you. Are we clear?
Yep.
Okay, I'm fair, okay? I'm not wait till you come to heat transfer, okay? Okay, if that's the case.
Hi, Professor. Sorry, before you go, can I just ask a quick question about the shear flow design?
Yes.
So you said the shear flow direction, like only the direction matters in the web, right?
Yes.
So in a beam, as long as the shear flow is the correct direction in the web, in all other sections, as long as it's continuous to the web, is that okay?
Yes, you got it.
Okay, perfect. Thank you.
Okay, have a fantastic weekend, okay? And
Eugene?
don't study. Yes.
I just had a question. I just wasn't sure because I missed yesterday's lecture and stuff. Have we actually come up with a date for our midterm or no?
No, not yet, not yet. I promise you. So give me to tomorrow, okay? I know you have heat transfer coming. When's your heat transfer?
I don't know off the top of my head. I
think
know
it was Friday. People said Friday.
Yeah, I think
it's on the 19th.
Friday. Like there's like
Dr.
like
Judd
7th.
is always like, okay, Dr. Judd is always messing me around. Okay, I'll probably do it like 2 days before or 3 days after. Okay.
Yeah, I know whatever day we have Judd's. I know that there's also a stats midterm that some people have 2 days before it. Like that we have one on like I have one on the Wednesday and the Friday.
Stats one on the Wednesday.
Yeah.
Okay, so that leaves me on a bloody Thursday again.
No, can we just do it on a Saturday?
Okay, you know what? I will put a vote. Okay, then you don't mind doing on a Saturday?
No.
I don't.
Okay.
Yeah, I don't really care. I have not school.
Okay, so I will consider Saturday, and then I will ask the class. Okay, it's difficult to schedule, but I want you guys to do well. Okay, if you guys sing like the Titanic here, I'll go crazy. I'll tell you guys that. Okay.
Yeah, it would be if it is gonna be sometime like on a Saturday. It would be really appreciated to like have it like set earlier so that I could like ask for it off of work and stuff.
Okay, I will do that. Okay.
The other thing I just wanted to mention is I did send you an email earlier this week. Just it's more of like a personal note, and you just never responded, so I wasn't sure if you got that. But
Okay.